Hi everyone, so now we are going to learn about the orbital, radii and energy level of hydrogen atom in Bohr's model. So for a Bohr models, we know that it is actually the electrons surrounded the nucleus with a fixed orbit, where this fixed orbit will have a discrete energy level. Okay, means it will have a fixed energy and fixed angular momentum. So how do we derive the orbital radii for the electrons in each orbit? Because we have several orbits which has quantum number n equal to 1, n equal to 2. So when is n equal to 1, what is the orbit of the electrons? Because it's according to the orbit. So how we are going to derive this orbital radii? So according to this circular motions of electrons, so it is actually has centripetal force. So for circular motions, we know that there is a centripetal force that act on this electron, where this force is equal to mv squared per r, right? And because it's actually two charges, because we have electron charge and also positive charge, they actually attract each other. So this centripetal force is actually from the attractions between the attractions force between the electrons and positive charge in nucleus. So when we have these two types of these two charges, so the force will be equal to, so we know that for the attractions force between charges is actually Q1 Q2, the multiplications Q1 and Q2 per 4 pi epsilon naught r squared. So r is the distance between the two charges. So at here, the two charges is separated by the distance between the orbit and the nucleus, where Q1 is the charges of, let's say it's an electron, then Q2 will be the charges of positive charge. So we have both same charge but opposite in value, but because force doesn't have any, when we calculate the force, attraction force between the two charges, we usually don't include the signs of the charges. So we have both SE, so we have E squared, because Q1 is E, Q2 is also E, but one is positive value, one is negative value. And then we have 4 pi epsilon naught r squared. So these two equations are actually equal. Okay, so we have mv squared per r equal to E squared per 4 pi mu naught r squared. So this is actually from Newton's second law. Why? Because it's actually the change in momentum. Okay, let this one as equation 1. And then from what we have learned in Bohr models, so we know that from Bohr first postulate, we have mvr equal to nh per 2 pi. mvr is actually the angular momentum of the electrons in a fixed orbit. So in other words, when we know that this is actually the hydrogen atom in Bohr models, so it has angular momentum in each orbit. So we have these two equations. So from these two, we can get the radius of the electrons on certain circular orbits. So by equations 1 divided by equation 2, and we square this second equations, so we will get something like this, mv squared per r. So this one divided by second equations, and when we square it, so we will have 1 over m squared v squared r squared. Okay, and then e square per 4 pi epsilon naught r square, and then this one will be n square h square per, sorry, is 4 pi square over n square h square. So the one that we can eliminate, we eliminate first. So 4, eliminate 4, and then r square we can eliminate because left hand side and right hand side we have r square in the same side or same positions, and then we have v square being eliminated. Then m here, and we have nothing. Okay, so that's it. And then here we have 1 over mr. Okay, and then here we have e square pi over, so left epsilon naught and n square h square. So rearrange this one in r in terms of other units, so you will get that r is equal to epsilon naught h square per n pi e square times n square. Okay, so why I put my radius or the orbital radii in this form? Why? Because all here in this outside brackets here are actually all constants, right? Because epsilon naught is actually equal to 8.85 times 10 to the power of negative 12 f per meter, and then we have h, which is your Planck constant, is 6.63 times 10 to the power of negative 34 joule per second. And then your mass of electrons, this one is your mass of electron, is 9.11 times 10 to the power of negative 31 kg. So pi, we don't need to say pi, and then E will be equal to 1.6 times 10 to the power of negative 19 coulomb. So these are all actually constants. So in other words, your R is directly proportional to your n square. So when your n increase, your R will increase. So that is why when we say n, when the orbits become further away from the nucleus, the n will increases because r is increases. Okay, now we are going to derive the velocity of the electrons, because when it is in a fixed orbit, it still has electrons that orbits around the nucleus. So how do you get your velocity for the electron? So by using equations 1 divided by equation 2, then you will get mv square over r 1 over mvr. So because 1 divided by 2, so you'll have the left hand side is this, and then the right hand side you will have 4 e square 4 by mu naught r square, and then 2 pi divided by nh. Same, we eliminate anything that is can be eliminated, and then we have this one v square, and we don't have, and r can be eliminated because we have r square and r 1 per r square and 1 per r square on the left and right hand side. So these equations were left. So on the left hand side we will have only v, and then for the right hand side we will have e square over here 2 epsilon naught, and then h, then 1 over n. So why I put it in this form, same here, because here all are constants. E as a constant, epsilon naught as a constant, and h as a constant. Okay, so means that v is directly proportional to 1 over n. Okay, so in short, if you substitute the value inside the equations of this and this, so you will get your radius for the first orbit, where n equal to 1, you will get this radius. And then when you get substitute n equal to 2 in this equations, the r equations, okay, in this r equation, then you will get your radius as this one. So if you notice that the radius is actually in increasing order, it will be increase and increase. Okay, So same with your velocity. So you can try to make a table for your velocity in different quantum number or different orbit. So after you have known how to derive the orbital radii of the electrons in Bohr models and also the velocity of the electrons in Bohr models, so we are going to learn about the energy level of hydrogen atoms in Bohr models. So what is actually energy level? So energy level is actually the total energy of electrons in certain orbit. So when we talk about energy, so we are related with kinetic energy and also potential energy. Cause potential energy. So before we start with this one, so from what we have learned just now, we have Newton's second law, where you have mv squared over r equal to e squared over 4 pi epsilon naught r squared. This is your first equations. So if you want to calculate Ke based from the Newton's second law, we have half mv squared. So if you rearrange this first equation, so this Ke will become half. So this one r move to the right. Okay, r move to the right, then you will get your mv squared is actually equal to e squared over 4 pi epsilon naught r. So in other words, you substitute this one into here, so you will get e squared over 4 pi epsilon naught r for this one, and Ke will be equal to e squared over 8 pi epsilon naught r. Okay, so this one is the kinetic energies for an electron. And then we can get Pe. So how do you get Pe? So because electrons have positive charge in nucleus will have attractive force. When we see the attractive force between the two charges, then it will have potential energy. So the potential energy can be calculated by negative Q1, Q2 over 4 pi epsilon naught r. The negative indicates that the potential energy by definition is the energy required to bring an electron from infinity to a certain distance from the charge. Okay, so we have this one as Pe. So now you have two charges with same value. So you have negative E squared over 4 pi epsilon naught r, because positive charge and negative charge has same magnitude but opposite in sign. So in other words, your total energy for electrons in certain orbit here will be equal to Ke plus Pe. Don't forget, when we say total energy must be Ke plus Pe. So substitute inside, what you get for Ke is 8 pi epsilon naught r, and then minus E squared 4 pi epsilon naught r. So this equation, so you will get negative E squared 8 pi epsilon naught r. So this is actually your energy level. We call this one as energy level. So if you notice here, this energy level is actually depends on the r, the orbital radii of the electrons. So we have get in previous, so we have r is equal to epsilon naught h squared n squared over pi me squared. So we substitute this one into the energy level here. So you will get that your En will be equal to negative E squared over 8 pi epsilon naught. So now your R is become pi me squared over epsilon naught h squared n squared. So you can eliminate the one that can be eliminated, and that's it. So rearrange and simplify this equation, so you will get this relations. So can you see this? So this is actually called the energy level. So energy level is actually the energy in certain orbit, the total energy in certain orbit. So this the energy level is actually depends on the n. So as your n increases, so because 1 over n will become smaller and smaller. So in other words, En will become more positive. So when we see the energy level become more positive, means the energy is actually increasing. We have increasing energy, become more positive energy. Okay, when your orbits get higher and higher or further away from the nucleus, means the energy of electrons will become more positive. So this is your conclusions for your En. We have these equations, so don't forget about these equations. So if you look at these equations, why I usually put this one together, okay, if you notice here, so I will put this one outside the bracket. Why? Because all these values are actually constant. So in other words, En is actually depends on the quantum number of the orbital orbits. So by substitute constants inside all this value constant, let's say you have your epsilon naught, which is equal to 8.85 times 10 to the power negative 12, and then you have your m for the electrons. So don't forget your m for electrons is 9.11 times 10 to the power negative 31 kg, and then your h Planck constant is 6.63 times 10 to the power negative 34 joule second, and then you have your E as 1.6 times 10 to the power negative 19 charge column. So substitute this value inside and you will get this one En in two different units. So we know that energy can be written in two different units. It's actually in electron volts and also in joule. So if you calculate using electron volts, means you doesn't substitute E inside, then you will get your value as negative 13.6 eV per n squared. So this one is in electron volts unit. And En can also be negative 21.7 times 10 to the power negative 19 per n squared joule. So this one is in joule, in unit joule. So this En is actually depends on n squared. Okay, it depends on 1 over n squared. Okay, now if you substitute n equal to 1, n equal to 2, so you will get this table. So if you look at this table, so this one, the one with n equal to 1, where we call it as a orbit that is nearest to the nucleus. If you look at this one, it has the most negative value. Okay, this one is negative 21.7 times 10 to the power negative 19 for quantum number 1 and 13.6 eV. And then if you increase the quantum number, then you will get 2 equal to negative 5.44 10 to the power negative 19 joule, and also negative 3.40 electron volts. So if you go down or go further away from the nucleus, so until your n is equal to infinity, in other words, your r is also equal to infinity. When it's go away from infinity, so your energy level will become 0. So it will become more positive. So your energy is actually increasing. So in other words, your second orbit will have a higher energy level than the first orbit. So we name this one. So when you have this one is n equal to 1. Okay, we have nucleus here. So the first orbit has quantum number q equal to 1. So this q equal to 1 we call it as a ground state. So the one nearest to the nucleus is known as ground state, and then when your n equal to 2, it's called first excited state. And then when it get higher in level, so we call it a second excited state. Okay, is it clear? So now there are few words, few specific terms that you have to remember for this energy level. So ground state, it means that when the quantum number is equal to 1 and it is the lowest energy level, you have the lowest energy here. So when we say ground state, lowest energy level, where is the nearest to the nucleus. And then when we say excited state, okay, when we say excited state means the state or the energy level which is higher than the ground state. So you have the second orbit, third orbit, fourth orbit, or we name it as first excited state, second excited state, and third excited state. Okay. Then when we say excitation's energy here, so what is meant by excitation's energy? So when let's say an electrons from n equal to 1, so it moved from ground state, so this one is called ground state, moved to the first excited state. So energy is being increases. So this change in energy we call it as excitation's energy. So it's the energy that required to move your electron from ground state to an excited state. It must be moving from ground state to excited state. So your ground state is always n equal to 1. Okay. So when we say excitations means moving from ground to a higher orbit or higher excited state. Okay. So let's say just now it moved from ground state to the first excited state, so we name it as the first excitation's energy. So it means that the energy required to move the electrons from the ground state to the first excited state. Let's say it moved to second excited state, then it called second excitation's energy. Okay, if from ground state moves to the third excited state, then it means third excitation's energy. So this is how you name it for excitation's energy. So how do you calculate your excitation's energy? By using En final minus ground state. Okay, by using En final minus the ground state energy, then this one is called your excitation's energy. Okay, then what is ionization's energy? When we say ionizations, okay, I believe that you have seen this terms. Ionizations means an atom become ionized, become an ion. So when we say ions, the electrons is actually far from the nucleus. It's already released from the attraction spots between the nucleus and the electrons. It is free to move. So now the atom is an ion. So when it's ion, means the electron is moving from ground state. So it is moving from ground state out of the atom. So means that your N will be equal to infinity. So how do you calculate the ionization energy? The minimum energy that required to remove an electrons from the ground state out of the atom. So this one is called ionization energy. So in other words, ionization energy will be equal to E infinity minus E ground. Okay. So that's it for your orbital radii and also energy level. I hope you enjoy. So see you later.